Hello, good day. I am Monica G. Gatela from BSED 2. In this video, we will try to solve this given problem. The problem is, determine the volume of the solid generated by the given region bounded by the curve y is equal to 4 times the square root of x plus 1 and y is equal to 4 times square root of x, and the line given y is equal to 6 and is revolved about the line x is equal to negative 1.5. So, in order for us to get the volume, we will try to use the washer method and the shell method. So now, the first thing that we're going to do in order to solve this problem is to graph the given functions in this problem. So now, to graph the functions, we are going to find first the value of x and y. So now, the first function that we have is y is equal to 4 times the square root of x plus 1. Now, if our x is equal to 0, what is our y? Okay, so we'll find the value of y. So 4 times the square root of 0 plus 1 is equal to 1. So our coordinates here is 0, 0, and 1. Next, what if our x is equal to 1? Y is equal to 4 times the square root of 1 plus 1 is equal to 5. So our second coordinate is 1 and 5. Okay, next, we will try to get the value of x and y in this function. So we have here y is equal to 4 times the square root of x. If our x is equal to 0, what is our y? So our y is equal to 4 times the square root of 0 is equal to 0. So our coordinates is at the origin, 0, 0. Now, what if our x is equal to 1? Our y is equal to 4 times the square root of 1 is equal to 4. So our coordinates here is 1 and 4. Now, we can already graph the given functions in the problem. So, here is the graph now. This is now the graph that we are going to solve. So this is the curve y is equal to 4 times the square root of x plus 1. And this is the curve y is equal to 4 times the square root of x. And the line y is equal to 6. And the axis of revolution is at x is equal to negative 1.5. Now, since our axis of revolution is vertical, therefore, it will be in terms of y. So each function in the problem will be in terms of y. So the first function is y is equal to 4 times the square root of x plus 1. We will make it in terms of y. So this will become now y minus 1 is equal to 4 times the square root of x. 4 times the square root of x over 4, and y minus 1 over 4. This will become now y minus 1 over 4 is equal to the square root of x. So in order to remain x, we will square the both sides with, So this will become now the square root of x squared is equal to y minus 1 over 4 squared. So x is equal to y minus 1 over 4 squared, or we will expand this. This will become now x is equal to y squared over 16 minus y over 8 plus 1 over 16. Next function is y is equal to 4 times the square root of x. We will also make this in terms of y. So this will become now y is equal to 4 times the square root of x. 4 times the square root of x over 4 is equal to y over 4. And now to make x, to remain x, we will again square the both sides. This will become now x is equal to y over 4 squared, or x is equal to y squared over 16. So we will use these functions to solve the volume of this problem using the washer method and shell method. So first, we will use the washer method with the formula v is equal to the integral of a sub y dy evaluated from a to b, where our a sub y is equal to pi times r sub 2 squared minus r sub 1 squared. So we have the formula v is equal to the integral of pi r sub 2 squared minus r sub 1 squared dy. So this will become now our formula. First, we will get we're here now in getting the r sub 1. So our r sub 1 is function minus axis. So this is y squared over 16 minus y over 8 plus y over 16 minus the axis is negative 1.5. So this is equal to y squared over 16 minus y over 8 plus 25 over 16. So we will get the r sub 1 squared. So we will square this one, y squared over 16 minus y over 8 plus 25 over 16 squared. So we will expand this one. This will become now 1 over 256 y raised to 4 minus 1 over 64 y cubed plus 27 over 128 y squared plus 625 over 256. Next, so this is our r sub 1 squared. Next, we will get the r sub 2 squared. So r sub 2 is equal to function minus axis. This is now y squared over 16 minus 1.5. Y squared over 16 plus 3 halves. So now we will get r sub 2 squared. We will square this one. This will become now y squared over 16 plus 3 halves squared is equal to 1 over 256 y raised to 4 plus 3 over 16 y squared plus 9 over 4. This is now our r squared, r sub 2 squared. We'll get now the r sub 2 squared minus r sub 1 squared. So this is now 1 over 256 y raised to 4 plus 3 over 16 y squared plus 9 over 4 minus r sub 1 squared is equal to 1 over 256 y raised to 4 minus 1 over 64 y raised to 3 plus 27 over 128 y squared minus 25, 64 y plus 625 over 256. So the answer is equal to 1 over 64 y cubed minus 3 over 128 y squared plus 25 over 64y minus 49 over 256. We can now use the formula, and our boundaries is RA is equal to 0 and RB is equal to 6. These are the boundaries found in the graph that I have showed you earlier. So we can now use the formula V is equal to the integral of pi times 164 over 1 over 164 y cubed minus 3 over 128 y squared plus 25 over 64y minus 49 over 256 dy evaluated from 0 to 6. We will now integrate. This will become now pi times 1 over 64 times y raised to 4 over 4 minus 3 128 times y raised to 3 over 3 plus 25 over 64 times y squared over 2 minus 49 over 256 y. So this is pi 1 over 256 y raised to 4 minus 1 over 128 y cubed plus 25 over 128 y squared minus 49 over 256 y evaluated from 0 to 6. So we can now perform the formula, and this will become now pi 1 over 256 times 6 raised to 4 minus 1 over 128 6 raised to 3 plus 25 over 1286 raised to 2 minus 49 over 256 raised to 6 minus 0, since our A is 0. So now, using the calculator, the result is 1,185 over 128 pi, or approximately 29.08 cubic units. So this is our volume 1. Next, we will get the volume 2. Same process earlier. We will get first the r sub 1 squared is equal to negative 1.5 squared is equal to 9 over 4. This is our r sub 1 squared. Our r sub 2 squared is equal to y squared over 16. So this is equal to 1 over 256 y raised to 4 plus 3 over 16 y squared plus 9 over 4. This is our r sub 2 squared. Using the formula, we will now, our volume 2 is equal to the integral of pi raised to 1 over 256 y raised to 4 plus 3 over 16 y squared plus 9 over 4 minus 9 over 4. Evaluated from 0 to 1, since our A is equal to 0 and our B is equal to 1. Now this will become now 1 over 256 y raised to 4 plus 3 over 16 y squared dy. Using the calculator, the result is 81 over 1280 pi, or approximately 0.21 cubic units. Now to get the total volume, we will add the volume 1 and the volume 2. So the total volume is equal to volume 1 plus volume 2 is equal to 29.08 plus 0.21 is equal to 2,929 over 100 pi, or approximately 29.29 cubic units. So this is the volume of, this is now the volume. Next is, we will check if we use the shell method, if it will have the same volume. So this time we will use the shell method. Shell method, we have the formula V is equal to A sub x dx evaluated from A raised to B, where our A of x is equal to 2 pi times r sub x times h of x x. We'll now get first the r's of x. So our r's of x is equal to x minus negative 1.5. So this will become now x plus 1.5. And our h of x is equal to 4 square root of x plus 1 minus negative 1.5 is equal to 1. Using the formula, our a is equal to 0 and our b is equal to 25 over 16. These are the boundaries that we will see in the graph. So, using the formula, v is equal to pi times x plus 1.5 times 1 dx evaluated from 0 to 25 over 16 using the calculator. Our volume 1 is equal to 1,825,256 pi, or approximately 22.40 cubic units. So this is our volume number 1. Now, in getting the volume number 2, we will also use the same formula, and our r's of x is equal to x minus negative 1.5. This will become now x plus 1.5. And our h of x is equal to 6 minus 4 times the square root of x is equal to 6 minus 4 square root of x. Now, using the formula, our boundaries is our a is equal to 25 over 16 and our b is equal to 9 over 4. Using the formula, we have here v is equal to the integral of integral of 2 pi times x plus 1.5 times 6 minus 4 square root of x dx. Using the formula, well, to calculate this one, the result is using calculator, the result will be 1,403 over 640 pi, or approximately 6.89 cubic units. This is now our volume number 2. Now, to get the total volume, we will add volume number 1 and volume number 2. So, this will become now 22.40 plus 6.89 is equal to 2,929 over 100, or approximately 29.29 cubic units. So, as we can observe, we get the same volume in the shell method. So that's all. Thank you.